this section, we're going to examine confidence intervals for proportions. To take an example, let's say candidate A in a two-person election wants to know she is ahead in the polls. She randomly selects 500 registered voters and asks them who they plan to vote for. When the results are in, she sees that 260 out of the 500 favor her. In terms of proportions, 0.52 of the sample favors candidate A and 0.48 of the sample favors candidate B. Although it is informative to know this point estimate of the proportion, and reassuring for candidate A that more favored her than her opponent, we will learn a lot more if we compute a confidence interval on the proportion. To compute a confidence interval, we need the mean and standard deviation of the sampling distribution of the proportion. The formula for the mean is mu sub p equals pi, where pi is the proportion favoring candidate A in the population. The standard deviation of the sampling distribution of a proportion, also called the standard error of a proportion, is calculated by multiplying pi by 1 minus pi, dividing by the sample size, n, and then taking the square root. Since we do not know the population parameter pi, we use the sample proportion, or p, as an estimate. The estimated standard error of p is calculated by taking the square root of the sample proportion multiplied by 1 minus the sample proportion divided by the number in the sample. Applying our formula, we find the estimated standard error of the proportion is 0.0223. The next step is to calculate z for a 95% confidence interval. The value is the number of standard deviations from the mean needed to contain 95% of the area of a normal distribution. We can use the normal distribution calculator to find that the value is 1.96. Before we work out our interval, we need to correct for the fact that we are approximating a discrete distribution with a continuous distribution. In other words, our distribution is based on voting preference, which is either candidate A or B. It is not a continuous distribution, like the normal distribution. This correction involves subtracting 0.5 divided by n from the lower limit and adding 0.5 divided by n to the upper limit. If n is large, this correction makes very little difference. However, it can be important with small n's. So the formula to compute the confidence interval is the sample proportion, p, plus or minus z sub 0.95, multiplied by the estimated standard error of the proportion, plus or minus 0.5 divided by n. This gives us a confidence interval with a lower limit of 0.475 and an upper limit of 0.565. The confidence interval is shown in the purple box. The interval extends 0.045 from the proportion in both directions. This means that the margin of error is 0.045. What does the confidence interval tell candidate A? Well, in terms of percent, it is likely that between 47.5% and 56.5% of the voters favor candidate A, and the margin of error is 4.5%. So you can see that the confidence interval may leave candidate A a little more nervous about the main vote, because now she sees that she does not necessarily have more than half of the voters favoring her. What about candidate B? Remember that our vote was dichotomous. Voters chose either candidate A or candidate B. We've already computed the 95% confidence interval for candidate A, which means we can easily work out the confidence interval for candidate B by subtracting the limits for candidate A from 1. To compute the interval for candidate B, take 1 minus 0.475, which equals 0.525. This is the upper limit. Then take 1 minus 0.565, which equals 0.435. This is the lower limit. The confidence interval is shown in the purple box. In terms of percent, this means that between 43.5% and 52.5% of the voters favor candidate B, and just like candidate A, the margin of error is 4.5%. The confidence interval leaves candidate B feeling more hopeful because it is possible that over 50% of the voters favor her. Always remember that these margins of error, 4.5 in this case, are for the percent of voters favoring candidate A or favoring candidate B. They are not for the difference between the percent favoring candidate A and the percent favoring candidate B. The margin of error for differences is 9%, which is twice the margin of error for the individual percent, which is 4.5%. When the choices are dichotomous, like in our example, the margin of error for the difference is always double that for the individual. Keep this in mind when you hear reports in the media, since they often interpret the individual margin of error as if it were the margin of error for differences.